In this video, we are going to investigate special cases of systems of linear equations. So we are going to be looking at graphs of all three of these situations. The first being one solution. So if a system has one solution, we are looking for the graph to intersect, or the lines to intersect, one time. If a system of linear equations has no solution, we are anticipating that the graphs would never intersect. So we're going to look at these situations right now. One solution, the first thing I'm going to do is use my knowledge of graphing to determine the slope of both of these lines. Even though I can't see the slope of the bottom line, I know that it's -1. So the slope of the top line is 1/2, and the y-intercept is -2. The slope of the bottom line, even though we're out of order here, the slope is -1 and the y-intercept is 1. So I'm going to graph the first line starting at -2. And the slope tells me to go up 1 and right 2. Or down 1 and left 2 would be the exact opposite of that. Draw my line. I'm going to graph my second line with a y-intercept of 0, 1 in red. So here's 0, 1 on the y-axis. If the slope is -1, I write that over 1. It's telling me that the slope means I should go down 1 and right 1 from my y-intercept. And there is my intersection point. So this graph intersects one time, and it happens to intersect at the ordered pair 2, -1. That is the solution to this system. It is one solution because the lines intersect one time. Now we're going to look at no solution. You'll notice before we even begin to graph that both of the slopes are -1. Okay, so we have the same slope. We already know from previous units that the same slope with a different y-intercept gives parallel lines. So if we have a slope of -1 for both lines, but the y-intercept is 0, 1, and 0, 3, we're anticipating that when we graph these lines, they are parallel. So the first one, I'm going to put the y-intercept at 1. The slope tells me to go down 1 and right 1. And then I'm going to graph the other line in red. It has a y-intercept of 3. And again, the slope is down 1 and right 1. So you should already see that we are creating parallel lines. Parallel lines never intersect, which means that there is no solution to this system of linear equations. Okay, so no solution would be parallel lines. They have to have the same slope but different y-intercepts. In the next set of equations, I'm going to make sure I get y by itself here so that I have both equations written in slope-intercept form. Remember that 4 and 2x are not like terms, so I will just write it as 4 plus 2x. For both of these lines, I'm going to look at the slope first. Both lines have a slope of 2. But what I'm also noticing is that both lines have a y-intercept of 4. If you went to graph one of the lines, you'd say, okay, the y-intercept is 4, the slope is 2. So I'd go to the y-intercept, 1, 2, 3, 4 on the y-axis. My slope tells me to go up 2 and right 1. Or the exact opposite would be down 2 and left 1. So I put my line on my graph, but you'll notice I'm going to graph the other line and it is exactly the same. So we're putting this exact same line over the line that was already there to begin with. This tells me that the solution to the system is that there are infinitely many solutions, because these lines touch or intersect at every single point. So when we graph both lines and they are the same exact line, that means that there are infinitely many solutions to this system.